Unless you either come to tutoring, come to Saturday Academy, email me. If there is something that is difficult on that study guide and you're not asking, then you will struggle with that same problem on the test. So after looking at the study guides, I gave you 30 minutes to look at them right now. What do we have questions on? Still, Halen, did you say five? So if you also need help with five, you know, okay. So Sarah is practicing her typing. I do want to make a change. We can leave it actually. Sarah is practicing her typing. The following table shows her words per minute. At what average rate of change in words per minute does Sarah type from W of 1 to W of 3? Enter your answer as a decimal rounded to the nearest 10. The only thing I would have changed is I would have just done this. Because I don't really like that they put it in function notation like that. Because I don't want you to think that they're just comparing the outputs. You're comparing the average rate of change from 1 to 3, basically. Or really, it should say T equals 1 and T equals 3. So I'll make that a little more clear. When you hear the phrase average rate of change, what should your mind automatically go to? The formula. Okay, good. Sorry, flagging. But is this a formula that I am providing you tomorrow? No. So you either have this memorized by tomorrow. You did have to memorize it in the last unit, so hopefully you already know it. It's the same as our slope formula. Sometimes you'll see it expressed in function notation, so let me just show you that at least one. But I like to keep things simple and not really change it a whole bunch because literally it is the same way you would find your slope of a linear function. You're subtracting your outputs and dividing it by the way you subtracted your inputs. Okay, so these mean the same thing. It'll always tell you now where to look. So it wants me to look for when T is 1 to when T is 3, what that average rate of change is. So let me write it as a coordinate, because you need 2 coordinates for that formula. So 163 is my first coordinate. 176 is my second. And to use this formula, you just make one of them x1, y1, the other as x2, y2, plug it into your average rate of change formula, and so on. So the way that I labeled it, I would do 176 minus 63, minus by 1, over 3 minus 1, which is x2 minus x. Question common mistake is people just subtract the outputs, which is not what you're supposed to do. You need to divide it by you're subtracting the inputs. I do need my calculator for that. I would recommend, like if math is hard for you, you could put this all into Desmos exactly how it looks. If you use a handheld calculator, you need to put the numerator in parentheses and the denominator in parentheses like that. Otherwise, it would automatically divide before subtracting, and you need to subtract before dividing on this. So 176 minus 63 is 113. 3 minus 1 is 2. And 113 divided by 2 is 56.5. It did say to round your answer to the nearest 10th. How many decimal spots is that? 1. The 10th spot is 1 decimal spot. 100th with like a TH would be 2 spots. 1000th, 3 spots. But 10th place is just 1 decimal spot. It's already at 1 decimal spot. So all I really need to do is type in 56.5. That's how you find average rate of change. Questions on that one? Questions on others? Dan?
Those questions.
You said 11? So for each description, identify the correct domain of each function, and we have different rows or different scenarios. Domain refers to all the what's, X's or inputs, independent variable, lots of things we call them. It's not asking about range in this one, so it's really just saying what are our possible X's or possible inputs, kind of like we did in that one activity. Notice our answer options are like phrases rather than just numbers. So hopefully you know the difference between positive and negative numbers. Integers means that it can't be a decimal, basically. So kind of like another way of saying whole numbers, but technically integers could be positive or negative, but this one specifically says positive integers. Anytime it says real numbers, it can be a decimal. And that's really like the only difference. So the first function, g of x, has this formula. What I would recommend is graphing it, seeing what it looks like. We did this in the very first, like, lesson 0 of this unit, where we looked if it's the domain from left to right to see if there was any, like, limitations on it. You can type in the function notation. I kind of don't want to have to go to my keyboard right now, so I'm just going to type in the expression 2 times the sum of x and 1, like that. And as we can see, it's a linear function. Does it go infinitely to the left? Yes, because it's going diagonally down like that, which means that the more left I go, like, it's still there. I mean, I have to go down too, but it is infinitely going to the left. Is it infinitely going to the right? Yes. So when there's no limit left or right, what do we call that for the domain? All real numbers for that one. It goes infinitely left and right. And it didn't say in this description that it had to be within a certain frame, so like all real numbers. Then it says function a of b gives the number of dog treats for every b bags. So you got it where it's only asking about the domain. Between these two variables, not variables, like, I mean, they are variables, but between the two things being compared, which would be the input? The number of dog treats or the number of bags? Incorrect. Number of bags. Because, well, a few reasons. The number of dog treats would depend on how many bags you have, right? Also, the function notation is the big giveaway. What's in the parentheses? A B, which stands for bags in this situation. So it's asking about the domain only, asking about what's in the parentheses. So you're coming up with what a reasonable number of bags would be. So here's my options. Let me full screen. Right. So when I'm talking about number of dog treat bags, could I have any negative amounts? So then I'm going to cross out everything that says negative. Not do that. I'm also going to cross out all real numbers because that would include negatives. So now I'm just down to these 3. Oh, and also can it be a decimal? Can I have a decimal of that? So anything that allows decimals, I cross out. I'm between these two. Does it say anywhere in this description that the most you can have is 10? So then I'm gonna take the one that says positive and like process of eliminating. And positive, negative, decimals for that situation. All right, for K of X, I have another equation, nothing else about it, so I'm gonna graph it and see what it looks like. You can use this function notation if you want. I'm just gonna leave this part off. And when I look at my graph, it is a U-shaped graph. And notice what's happening. We're talking about the domain, so we should be seeing if it goes infinitely left or right. But look what happens as I go up on the graph. It's getting wider. So will it go infinitely left and right? It's getting wider. Yes, it's adding more x's in the positive side and negative side. So if there's no limit, again, what is it? Good. And then last one for this one is this function gives the cost of renting a kayak for D hours up to a maximum of 10 hours. Between costs and hours, what's going to be my x, my input? The hours. If I were to graph this, this is how the graph would be labeled. And it's only asking about the domain. So that's why I want to make that distinction. We're talking about what the possible number of hours could be. Could I have any negative hours? So then cross out all the ones that allow negatives or say negatives specifically, because it can't be that. Could it be a decimal of an hour? All right, really, like, I know what you're thinking, like, yeah. But the way that they're charging, or the way it usually goes when you're renting something like for the hour, if you bring it back after an hour and a half, they're still charging you for the 2 hours. If that makes sense. So in this case, we're gonna exclude the ones about the decimals. And it does have a limit. When we're down to these two options and you read it again, the one that says whole numbers from 1 to 10 is the best option because it says a maximum of 10 hours. So questions on this one? Questions on others? Emily R. Number 7. So this one's a good question because there was not a lot of examples like this in the unit. However, what they wanted you to realize is that this is a linear function. And I know that's hard because we haven't seen an example like that where it's just a table. But I'll show you in a way that you could have done something that you've seen before. And then I'll show you maybe an easier way. So it says that it wants an equation that best models this data. So you could have looked at the table, maybe you could have looked at some patterns, we've done that before. What I might have done is just graphed it, which we did in unit 3. So in Desmos, I can hit this plus sign, hit table, and I can put my data in there to see what kind of shape it makes. Right, so when I'm looking for it, and I could zoom out and find it easier, but I already know it's like up here generally. Okay, and I can adjust the window to see it a bit like differently, maybe better. So what are you already noticing about those dots that it plotted? It's making a straight line. And if you really wanted to check, there's like another thing from unit 3. You could have done that linear regression thing. Where it puts a line on the graph. And you can see like it is a perfect straight line. The linear model goes right through every single dot. You can look at the statistics. It is perfect. So it is a linear function. Linear functions have what formula to them? And if you did this method, which is from unit 3, you could also see the slope and y-intercept there. So that's one way to get it. There actually is an easier way, we just never really had to talk about it, so I wouldn't necessarily expect you to know. If you're looking at this table, you should recognize that there is a pattern. What are the x's change, or sorry, the outputs? What are the outputs changing by time? $35. Consistently. So I did 179 minus 144, saw it was adding 35. I went and saw if that was the same throughout, and it is. And at the same time, the x's are changing by 1. When you see that it's adding the same amount or subtracting the same amount each time, that's also indicative of a linear function. And then you're finding your slope and y-intercepts to make the equation. Slope, another word for it is average rate of change. So whatever it is changing by would be your slope. And then your y-intercept, by definition, is when what happens? That is true. But there's a certain one that can also help in other situations. By definition, your y-intercept is when what happened? When x is 0. Do I have an x value of 0 on this table? So this is what you'll have to do, and I know it doesn't really make sense to have a length of 0, I get it. But to find what the y-intercept is, we're just gonna kind of work backwards. So like 1 is pretty close to 0. If I continue this pattern backwards as well, I will get my y-intercept. So 144 minus 35 is 109. And I use the calculator for that, as we could. And that's the same thing that Desmos just told me when I did the linear model. So I know that one, we didn't have a lot of examples of this unit, but one of the learning targets was to know if something's linear. So if you see that it's changing by the same amount each time it's a linear function, you should be able to make the equation if it is. Also, don't put any spaces or else it'll mark you wrong when you're typing that in. All right, questions on that? Questions on others? Twice. All right. If you do think of something for class end, let me know. One more thing to remind you of. I always post the key to the constructive response practice test. When I was checking it earlier, I was just checking about completion. You need to go back and check if it is correct. I'll publish it probably after 6 hours today. And you go and check and see if you're right. And if not, you should see at least what the answers should look like. So I wouldn't take the real things and kind of model it after. The last call to like a question right now. While I have your attention, something that did come up today. The Unit 4 test, after we retake it next Thursday, that is really it for like the 90% of your grade. The other 10% of your grade is your final exam. So as you are starting to prepare for final exams, I can show you the math for it, but let's be honest, like if you're having to calculate what you should get on your final to pass, like maybe that math isn't like that easy for you. So just Google final grade calculator. Whatever your current grade is, let's say it's 50%. And you would want a 60% to pass. Really, a 59.45 is rounding automatically to a D.
I thought it was Bob.
This is the minimum score you could get to pass. A 59.45 will round up to a 60%, according to Infinite Campus. All right, and then your final is worth 10% of your grade. According to this, I would need 144.5% on my final to get that grade overall in the class. I haven't talked to you about your final yet. There is some extra credit opportunities on there, but like just we haven't gotten there yet. Is it likely that this person will get 144.5% on their final? So what they need to do is make that other 90% of their grade, their current grade, better, like significantly better. And a way to do that would be by doing better on this Unit 4 test. The last time we are affecting that 90% of our grade is next Thursday, okay? So I can't stress to you how important this test is. Questions? You can upload it to Schoology.